Now, if you're just joining us, today on Moving Forward, we're taking a closer look at the groundbreaking research taking place right here at the University of Akron. Our next guest, Dr. Todd Blackledge, is focusing his research on something that most of us would rather stay away from, spiders. More specifically, spider silk. Thank you so much for joining us today.
Well, thank you for having me.
So first, tell us a little bit about your research. What are you doing studying spiders?
Well, spiders, it turns out, are a great group of animals to work on for a whole lot of questions in biology. I actually got my start on them, if you will, as a behavioral biologist. I was just interested in what are the behaviors that these critters use to build all of these very complicated webs. Yes. And then gradually, that just led into questions about the stuff that they were using to build webs, silk, because it turns out that it's a really incredible material, or really set of different kinds of materials that have all sorts of interesting questions of their own.
And how do you go about studying such tiny creatures?
Well, sometimes it's easy, sometimes it's hard. Studying silk itself has a lot of challenges because silk is so fine. If you imagine taking your hair and dividing it into 50 equal pieces, that's the thickness of the thickest silk spun by the biggest spiders in the world. So you have to have very specialized equipment to do things like measure the mechanical properties of it, or even really to see it under a microscope.
And what are some of the ways you hope to see this technology used?
Well, some of the most likely uses that you're going to see in the next few years are actually going to be in the medical industry, because right now the single greatest challenge is to obtain large quantities of silk. It's very difficult to get spider silk directly from an animal. They're not domesticated the way silkworms are, so you can only obtain small quantities of it. And in a laboratory, nobody can replicate the processes that spiders use to make their own silk well enough to mass produce the fibers. So the initial applications will be for medicine, where you need a very tiny amount of material for surgery and wound repair, tissue regeneration, applications like that.
And have any studies like this ever been conducted before?
Absolutely. There's been a fair amount of research using mostly animal models looking at the biocompatibility of spider silk with tissue and the efficacy of silk to help regrow tissue. So for instance, you can use these very thin silk threads as guides to regenerate nerve cells, for instance.
Wow. And how soon would you hope to see this kind of technology being put into use in the medical field or otherwise?
I think you'll see it begin to creep into the medical field over the next decade. There's still a lot of challenges, though, that have to be overcome before it's really going to become mainstream.
And how are students being involved in this research that you're conducting here on campus?
Students are involved in all facets of the research. We have graduate students both in the integrated bioscience program and in polymer science working in the lab studying silk, master's students, as well as a whole lot of different undergraduates. And their involvement really depends a lot on their own motivation and interests. Sometimes the students just kind of want a job and think it's a little creepy but a little cool, and so they want to work in the lab, maybe feeding spiders, helping us to take care of animals. Other times they come in and they're really jazzed about a question they have that they want to learn the answer to about spiders, spider webs, or silk. And then they really build their own very significant research project that sometimes leads to publications even.
And can you tell us about some of the different kind of spiders that you study?
A lot of our work focuses on orb spiders, which build those classic wagon wheel shaped webs that you see at Halloween. But one of the unique features of my lab is that we take a very evolutionary perspective on spider silk, and so we're interested in not just what do these orb weaving spiders do, but what were the ancestors of these spiders like, and what happens to silk when you evolve a new type of web, like the cobwebs that you see in your basement.
And what is it about the silk that spiders produce that makes it so strong and so useful?
So the usefulness of the silk stems from a couple of different qualities. Like you said, the silk is very strong, but it's also very, very stretchy. So this combines together to make the silk very tough. So if you imagine you took a rope with a bunch of weights up to the top of the building and dropped those weights and asked, does the rope stop the fall of those weights? That depends on how tough the rope is. Can it stop large amounts of energy without breaking? Silk is among the toughest materials known. It's actually 3 to 5 times tougher than Kevlar, a fiber that we engineered to be used in things like high-performance kayaks and bullet-resistant armor. So that property is really what a lot of researchers are interested in taking advantage of. But there's a lot more that silk offers. In some ways, spider silk is the ultimate in green chemistry. You have these incredibly high-performance fibers that are being produced inside living organisms in ambient conditions using the same basic building blocks as your skin and your hair. And that's really different than our synthetic fibers like nylon, rayon, Kevlar, and so forth that demand relatively caustic chemicals, high temperature processing, and cost a lot of energy and potentially environmental degradation to produce.
And now the question that I know is on everyone's mind, would it be possible for there to be a real-life Spider-Man using spider silk?
A real-life Spider-Man, yeah, get asked that question a lot. You'll never see anything like Peter Parker in the comic books shooting webs out of their wrists. For one thing, silk doesn't shoot out of the spinnerets of spiders at all. It's actually pulled out of the spinnerets of spiders. Silk is also useful because it is such a thin fiber for very small organisms. If we're going to do things like swing from buildings, we're going to have to make bundles of fibers, lots and lots of fibers. It would take roughly 2,000 to 10,000 threads of dragline silk just to hold a person in air, even though it is so strong.
So what's your ultimate goal for this research in the future? Where do you hope to see it move?
In my personal lab, we're trying to build a comprehensive understanding of the role that changes in silk evolution have played in the diversification of spiders. So there's more than 42,000 species of spiders in the world. Compare that to mammals. Mammals, there's just over 3,000 species.
Wow.
All of these spiders use silk. All of them depend on silk throughout their lives, but they do it in many different ways. Some build capture webs, some don't. Some use silk as a drag line to float down from the ceiling and scare you in the middle of the night. Others don't. And we want to understand the role that silk has played in basically guiding the evolution of this tremendous diversity. Secondarily, we hope then that this is really going to play into efforts by other labs to make some of these technological advances, to figure out how to produce synthetic fibers that do actually match what a real natural spider can do.
Well, Dr. Blackledge, thank you so much for joining us today, and we look forward to seeing where your research goes in the future.
Oh, you're quite welcome. Thank you.
Today we've been speaking with faculty who inspired the University of Akron's current ad campaign, The Energy of Innovation. Before we speak to our next guest, let's take a look at one of the commercials.
What is the energy of innovation? It's a new way of looking at our world, of asking questions, seeking answers, and finding solutions. Like imitating nature by using spider silk to create new lifting devices, or using nanotechnology to replicate the adhesive properties of geckos. At the University of Akron, our students and faculty are improving lives here at home and around the world. Experience the energy. Join us at the University of Akron.